Now on this video, completing the square, we're going to turn quadratics into perfect squares. First of all, what does that mean? Now, you understand square numbers. If I had 7 squared is a square number because it's 7 times 7. So 49 is a square number. So we can do the same thing with quadratics. So instead of having 7 being squared, let's say I had something like x plus 3 being squared. So a number squared produces a square number. I have here a number being squared. Remember, a bracket is just one number. It will produce a square result, perfectly square quadratic. So by expansion, we know that would be x squared plus 6x plus 9. That's what's called a perfect square, or a perfectly square quadratic. If we had x minus 4 in here, that would be x squared minus 8x plus 16. Perfectly square quadratics. Now, if I gave you this one, say x squared plus 10x plus 25, is that a perfectly square quadratic? Yes, it is. So, what is the number inside the bracket that is being squared to produce that? Well, clearly it's going to be x plus 5. How did I get that? Take the number in front of x, the b value, and divide it by 2. When you divide it by 2, you get 5. Is 5 squared equal to 25? Yes, it is. So positive 5 is the number in the bracket. Works for negatives too. Let's say I had x squared minus 18x plus 81. Take the number in front of x, which is minus 18. Halve it is negative 9. Is negative 9 squared positive 81? Yes, it is. It's a perfectly square quadratic. So the number being squared is going to be x. Take away 9. Perfectly square quadratics. So let's now apply that to things that are not perfectly square quadratics. So let's say we had x squared plus 14x plus 50. Is that a perfectly square quadratic? No, it's not. It's not a perfectly square quadratic. If it was x squared plus 14x plus 49, it would be a perfectly square quadratic. It would be this. Okay, I'm sure we understand that quite well, but this number on the end is what determines if it's perfectly square. We have 50, we need 49, so what I'm going to do is I'm just going to make it into 49. So now, this here is going to be factorised. But to make sure I bring it back to the original 50, I'm just going to add 1 on the end. So over here, I'm just going to add 1 on the end. So my original problem, x squared plus 14x plus 50, in other words, 49 plus 1, is going to be x plus 7 all squared, which gives me the perfectly square quadratic, with my plus 1 on the end. That's what we're going to do. We're going to take something that's not square, add something to it, take something to it so it becomes perfectly square, and then do our calculations. Here's what it looks like. Let's try this one. Now, let's turn this into a perfectly square quadratic, also known as turning it into the turning point formula. I'll point that out at the end for you. So here's what I'd like to do. So I'm going to complete the square. This part here, the x squared plus 6x, is the main bulk of the quadratic. It's the number on the end that's the pest. That's going to determine what the perfect square is. So here's what I like to do. I take the x squared plus 6, I write them down together. Then I scooch the negative 2 over here a little bit so it's just out of the way. So inside that bracket is going to become a perfectly square quadratic. But what number do I need to write in there so that it becomes a perfectly square quadratic? Well, half of 6 is positive 3, positive 3 squared is positive 9. So if I put positive 9 inside the bracket's a perfect square. I have a problem with the equal sign though, because this line up here is now not exactly the same value as this line down here. This line down here is now 9 units too big. So I fix it up by taking 9 units off. Add something in here, take something away out there to be able to balance it. Now, the line above and the line below are exactly the same value. And then, just continue on. I know the contents of the bracket is a perfectly square quadratic. So what number squared is it? Well, we just worked it out. 6 divided by 2 is 3. Then outside the bracket I've got minus 2 minus 9 is minus 11. So that quadratic there, in its completing the square form, or its turning point form, is that quadratic there. And that's what we're going to be doing. Taking these things that are not perfect squares, turning them into things that are perfect squares. Turning point formula. Now, in class I've been getting you to do exit cards at the end of a lesson to see how you're travelling. I'm now going to start introducing entry cards. I'm going to put 2 problems up on the board, and to get into class next lesson you have to show me these 2 completed. So give me a moment, I'll rub this off and write your 2 questions up for you. Now, here's your 2 entry questions into the class. You show me these 2 completed when you enter the room next lesson, so I know you've watched the video and you've understood. And by the way, if you're doing these and you find that you're struggling, you just really don't know what to do, that's not a worry. You just let me know when you walked in, show me your attempt, and then I'll be able to conduct the rest of the lesson based upon what you're able to show me that you can do, and I'll be able to build upon that. Remember, there's no things that are wrong, they're just things that we can improve upon. So have a go at these, show me what you can do, and that's how we're going to start our next lesson off. So good luck with them.